Class only makes sense when we start talking about more complex data structures, like the ones that we're going to see in the third lesson, which is the data frame, which is a rectangle of data. Same thing, it gets really, it's just confusing. I don't even know what's the difference between row and class, for example. So for now, the type refers to the most basic component. Is it a string or a character? Is it a number? And then you can compose them to create more complex data structures. And the rectangle called data frame is of class data frame, actually. And actually, I'm going to just to make it a bit more concrete. Let me just demonstrate that. Empty cars, for example, is a data frame, so I can say class. And it tells me that it is a data frame, but if I say type of, it is a list. So the point that I think this lesson is trying to make is the most basic type of element. This, at the moment, is not so important of a distinction, but later you will see that there is one difference in type that is very subtle that bites people very often, which is the difference between what is called a factor and a character. So we're going to come back to this later on. So for now, just for you remembering that the function type of, just remember that one explains what the thing that you're querying contains. But there is an even nicer way to kind of get a quick glance of what the type of something is. And that is with the function str, which stands for structure. So you can say str, actually let's do it on the source here. We can say str animals. What's going on here? What happened before? And we get a bit more of information. We get what we were looking for. It is a character, but in a summarized way. It also tells me kind of how long it is, right? How many elements it has. And then, because they fit here, it gives me the 3 elements that it has. But if it was a much longer object, say that I want to store the object 1 to 500, what do you think this is going to create? That could be. There is something similar to that, which is the function matrix that does something like that. Let's do it simple. What would that be? It is a set, but in this case of numbers between 1 and 2. And if I do 1 to 500, a set of numbers from 1 to 500. It prints super long, right? So what would happen if I ask this, say that I want to store this in an object called X. There we go. So if I print str of the object X, then, and this is the point I wanted to demonstrate, the function str provides a summary that is very kind of space efficient. Instead of printing the entire object X and ending up with a very long output, I can kind of summarize the whole thing in just one line with the function str, right? So this is all I need to know. It is an integer between 1 and 500, and it shows me just a few that fit within the width of my screen. I don't need to see all of them to understand what it is. str is a very good friend. Use it in all sorts of contexts. It's very, very widely used. So, and also it's very good for you to know it, because unfortunately there is another function called structure. So str stands for structure, but if you want to call the function structure on this is not what you want. It's going to do something still different, right? It's not going to print the output that you want, okay? So that's probably why one of the most important things, just to know that the one that you want generally is as soon as you get some kind of data in R, you're going to want to kind of explore what it is, what type of data you have, and structure will give you a very nice summary. So vectors, we have jumped from the kind of atomic level with the string or the single number or integer to a more kind of molecular level, right? And we are now building every time, we're going to end up with some kind of very cool organic compound that smells beautifully when we have, data frames or things that are complex like that. Other structures that are mentioned here that are built by, composing these things together include matrices, which is something like what you mentioned before, data frames, factors, arrays, and so on. I don't know why it's mentioned here. For now, we're not doing much with it. There is a challenge. There's a bunch of challenges here, really. So my proposition is for you to go to you will see a page that contains a bunch of challenges. Just choose one of your choice, whatever you feel comfortable with, and get to work with it. The reason is because the Carpentry is very much based on research on how people learn, and all these concepts, just by looking at them and listening about them, won't help you much until you try something. So, I know you're tired, but it's good to kind of push a little bit more and try get your teeth into one of these challenges. I'm going to give you a few minutes while I read what's coming next. Yes, exactly. So the heading that follows that is subsetting vectors, right before that. So the challenge, the first sentence of the challenge that I propose says, we have seen that atomic vectors, blah, blah, blah. Sure. Yeah.
I have so many windows.
Yeah, I know. Let me see what would be a nice type. Oh, that one. Let me see. This one. This one is kind of nice enough. Right? So that should, let's see where you land with this. Yeah. So you should land here on the home, and then you will navigate to introduction to R. And then here you can use the left menu and choose challenge. Okay. Okay, don't worry if you haven't finished yet. Sometimes actually it is, that's the way I train myself many times. I just hit, if I go to a lesson that I'm not familiar with, sometimes I go first to the challenge, even before I learn the concept. I try it, and then I go and learn. It sometimes works better if you first struggle a little bit. There is a lot of research on learning that says that if you don't that learning is effortful. It's a lot more about retrieval from your brain than actually feeding your brain. You may be watching a video, but only when you try to remember what you watch is that you are going to be creating links between your neurons, and that knowledge is going to be, be more retrievable in the future. So the challenges are really the entire focus of the lesson. So what I would recommend is, even if we are not able to cover every detail here, maybe in a week from now, when some of this knowledge has already disappeared, go back to the challenges and try to hit them, and only by noticing what you don't remember, then go back and pick those things that are misplaced. That would be like a time-efficient way to only learn or relearn what you kind of forgot. So the point of this challenge basically is to present the issue of, well, what do you do when, it's clear that if you do, if you concatenate 1 and 1, it's fine. I can give you a vector that is going to be of the same type, right? So 1, type of, that's why probably you see, I did the completion. So if I ask for the type of 1, it's a double, and if I ask for the type of 1 concatenated with 1, I still get a double. But as soon as I start mixing things of different types, what happens is this phenomenon of coercion. Whoever created this idea of concatenating things together had to come up with a system. So, well, what do you do if you give a string and you give a number? So for you, does it make sense what happens? So, let's see. What happens here is that I get a character, right? And if I print the concatenated object, 1 and A, basically 1 was converted to a string, right? Why do you think that, 1 was converted to a string and A was not converted to a number instead? Because you can. So generally, the coercion rules are somewhat arbitrary, but somewhat they make sense as well. I can create a string that contains something that looks like the 1, but I cannot compute string 1 plus string 1. I can compute number 1 and number 1, but not string 1 and string 1. So I have lost the properties of 1 as a number, but at least I can represent that with a literal string, right? So coercion is, it also bites a lot, and actually there is a package in development now, is already available. It's called Vectors, that tries to create more consistent coercion rules, because the coercion rules that come by default in base R sometimes do really weird things, that you don't expect. So that's pretty much the takeoff, the takeaway of this. Also, something like this is still a double, because if this, what do you think here is going to happen? Things get interesting, right? Is 0 equal to false? Yes, true. Is 1 equal to true? Yes, true. Is 1, if 1 was equal to true, can 1 be equal to false? No, right? So I should get false. So doing logics, math with logics can be a bit confusing, but as you will see later on, it is very, very useful. You can do something like mean of true, 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 I will give you a number, because true gets converted to 1 and false gets converted to 0. So you can calculate the mean of all these after they have been converted to their number representation. But interestingly, this is actually confusing because the only thing that is fixed is that 0 is false. But if you say, 4 equals to true, no, actually no, this is, no, fine. Okay, that was the takeaway. So coercion, right? In the challenge, there are maybe other kind of details, and if you do them all, you may discover some things that we haven't covered in this lesson. But I think for now we'll call it done. We're going to move to something that is super useful, which is, well, now that we have, now that we are able to build bigger data structures, how do we access some components of it? And where is this going? Well, it is going to the point where you have, say, a data set, and you want to, subset only, the values of the column X that are greater than 4, or, remove the missing values. All these operations are operations of subsetting within a data structure, right? So that's exactly what we are going to do now. Are you still good to go? Do people need a little break now, or we can push? Try to speed up a little bit. Probably 20 more minutes. Yeah. Okay. Cool. So the next section is subsetting vectors. And the idea is the following. We already have some objects here, for example, animals. Right? Remember, it was, we had mouse, rat, and dog, and we want to get rats. What we can do is refer to the index, so the position of the object that you want to extract, and we use this, that is actually a function, the function extract. That's what how you pronounce it, with the number of the position that you want to extract. So if I run this, I should get rat. If you want to convince yourselves that the square bracket is a function, you can do question mark. If you do this, it won't work, but for special things like square brackets, you can do backticks and question mark, and that will indeed pop up a help file of the function extract. Basically is the name of the help file, but the functions are square brackets and double square brackets, which we are going to see later on. So if you want to learn all the details about this function, go to the help file, and you will, one very important argument that almost no one knows about is this one. People use, so I'm going to show in a moment some of the dangers of square bracket. And the solution is going to be this argument drop. So what if instead of just pulling one object, say rat, what if I wanted to pull rat and dog? What should I put in here? 2 and 3. Is it valid to do something like this? Remember, how did we create? Well, let's try. Let's see what happens, right? So let's try this. It doesn't work because what we want to do here is pass a vector that contains the numbers 2 and 3. So what we want to pass is something like this, right? And now this should work. One other way is, remember the column notation that we discussed before? So with 2 and 3, we do the same thing, just a sequence from 2 to 3, in this case the numbers 2 and 3, and we obtain the same result. But more interesting, what happens if happens if I do this? What should I get there? Remember what animal it was? Should I get any dog when I call this, for example? No. Should I get, how many mouses should I get when I run this? Excellent. So this is useful later on when you are doing kind of lookup tables. Imagine that you have a table of grades, 10 is excellent, 5 is so-so, and then you have a table containing all the results of your students. This kind of operation later on is going to look up each result and add it to the table. Sorry, maybe it's not something that we need to discuss right now. But subsetting is not only subsetting, and this is the point of what I'm trying to say. Subsetting is actually a misleading word because you can, subset suggests that it's only to reduce the number of things, but you can use subsetting to actually expand the number of things, simply by repeating the index that you want to pass. And one that is commonly that may bite you, and that's why I want to kind of show you. So what would happen if I do this? What do I get there? So I say animals index 4. Do we have a fourth element in elements? We don't, right? So I got an egg. What is an egg? Just not applicable, right? Like not a number. Well, in this case, it's just what we call a missing value, right? In R has this representation of missing values, and it is an egg.